Healthy air is one of the many things we take for granted, but just how clean is the air we're breathing? Air pollution still remains as one of the key environmental challenges in the 21st century. Whether it's in class full of students or fitness clubs, indoor air quality may pose serious health threats. Elon Musk once said, "Engineering is the closest thing to magic that exists in the world." This is where we, AUI engineers, intervene to tackle such challenge with a revolutionary design idea.
Following the environmental problems the world is facing today, our team decided on working on APD, which is an air pollution detector and air purifier, to help reduce pollution and provide our customers with a good quality air.
So now we're going to talk about the air pollution detector mockup. Beginning first of all by the components, we have the Arduino Uno, we have the CO sensor, we have the red and green LEDs for indication, and of course the breadboard that links everything, and finally the power source. This video will be a demonstration of the project. We have a safe environment and the green LED is turned on. Then we inject a simulation of air pollution, which is burning paper. As we can see, the red LED immediately turns on. And when we go back to a safe environment, the green LED turns on again. So as we can see, it is fully precise, it is fully automated, and it is perfectly safe as we can see.
Our team journey was purposeless at first, even though it involved tension through some decision. We were able to cooperate to meet our goals and perform accordingly.
Project management is one of the most essential parts in the EVP, thanks to the solution it contains for time and cost constraints. As you can see, using the WBS we can identify different phases that our project will go through, where the time span is subject to change. This table will be the input of next charts. The CPM per charts plays the same role in design engineering as flow charts in computer science. It explains the flow of the phases and determines the critical path, which is an important concept for managing different departments. Also, we have the Gantt chart, which is used to visualize the timing allocated for every phase of the project as a schedule. And we have the values presented in these tables are costs that will be incurred during the production, and the cost of the raw material, which make us able to determine a point called the break-even point, where the profit is equal to zero.
Now moving on to the requirements for the prioritized table, we identified our APD project requirements following our customer needs and then organized them according to the level of importance to be able to recognize the important requirements and others that may be compromised.
Our objective 3 represents the necessary requirements that project APD is fundamentally about, which is functionality, safety, low cost, and efficiency.
After conducting a customer recommendation survey, we were able to identify our project requirements and constraint specification. Moreover, we made sure that our product follows all the engineering requirement properties.
We were able to speculate in this benchmarking table our product standing in the marketplace against similar competitors. And as we can see here, there are some predictions to the APD's prominence in terms of cost and response time.
For the simple analysis, we made sure that our product is societal, as this device is an opportunity for different companies to provide customers with good quality air. Moreover, we made sure that our project is technological, environmental, ethical, political, economical, and most importantly, legal.
First, we have the black box, which represents the input, the function, and the output. Secondly, we have the function tree, which represents the sub-functions in order of execution, from left to right usually. Then we have the function structure, which represents a combination between the black box and the function tree. Then we have the reverse engineering. It contains the prediction, the purpose of the product, observation, how do we think it works, disassemble, how does the product work and how is it made.
The QFD table we relied on reflects our customer's voice as specifications with its level of importance.
The house of quality is really important for building the project, since it has many roles, like showing the relations between customer and engineering requirements, also for example showing how does an engineering requirement affect another one, but most importantly to calculate the absolute and relative importance of every requirement there is.
We base the APD on the Carnot model analysis. Our basic quality is to measure and purify unhealthy air. The performance quality is based on accuracy, speed, and economy. Then the excitement quality is to display the look and feel.
In the concept development part, we have the morphological chart, which aims to enumerate all possible concepts for every function needed in the project to kind of try and conclude one best possible combination. Then we have the design solution space tree, which sketches the data of morphological chart using shapes and arrows that link every function of the project to the exact means we chose for the final concept.
In on to concept evaluation, in the Pugh matrix and decision matrix analysis, we analyze the different possible concepts to choose the best alternative. Based on these results, we can say that concept 1 is the best solution since it's the most affordable and efficient solution to our project mission.
Moving on to the embodiment part, we have the important chart representing the engineering design process. The aim of this chart is to combine the data mentioned in all previous charts into one that starts by mentioning the customer requirement, the specification needed to achieve that requirement, the conceptual solution, its embodiment, then finally the specific details of the product used.
Design for X is divided into three categories. DFA, designed for assembly, meaning that we have to think about the best ways to assemble APD through assembling the parts in an easy way and using a low number of parts. DFM, designed for manufacturing, meaning that we had to minimize the costs of APD through minimizing the tie to the market while keeping a high standard quality of the product. DFE, designed for environment, meaning making sure that the device is eco-friendly. Human factors and safety. We made sure that APD is built being the safest possible by making sure all electrical parts were out of reach to customers.
This is our business model Canva, which serves as a strategic tool for the APD project logistics, which is based on the value proposition as core for our health and well-being mission. The left side reflects the affordable resources of our business. Then the right side shows our customer-based logistics. Then below is our cost-driven structure with our multiple revenue stream.